AS-Level Binomial Theorem Exam Preparation Examples Part 2. Let's look at another example. Again, as I said in this chapter, because it's new in the new curriculum, I want you to refer you back to the textbook, and I want you to I refer you to an example that's more or less the same. So if you look in the textbook on page 89, example 48, that will be a typical example like this. Okay, but let's start with a new example. So I'm going to make it a bit bigger that you see even better. Okay. The coefficient of x to the power 3 in the expansion of this is this. So they give you the coefficient. Find the value of the constant p. Now, I think actually in the previous examples, we were looking a little bit at this kind of example already, but this is now straightforward. Okay, so the very important part, or the breaking down is a bit different, is that I first must find the r plus 1 term, okay, in terms of r. So I'm going to say, because there's a 5, I say 5 over r, so I get a general term. Then I'm taking the first term, okay, and let me just write down, it's actually good if I first write down this bracket. So 1 minus px, and that's to the power of 5. Okay, so I'm doing it, I'm getting the first term, and I put it to the power 5 minus r. And I get the second term there, and remember to grab that sign, and it's to the power of the bottom 1r. And now I break it up. Okay, so this is 1, and it's 5 minus r. This is negative p, and it's going to be, okay, 1 to the power anything will just be 1. And then this will be, so this is actually just you could have actually used that special case. Now, this is negative p, I'm breaking it up just to r, and then x to r. So I'm actually just breaking that part up. Okay, now, I'm actually just focusing on this x term. Okay, the rest I will use later. So for the term x to the power 3, which they say there, we equate x to the power 3 equals x to the power r, that part. So therefore, we're going to say that r, we take the indices because the bases are the same. So r is equal to 3. And now we're going to get the specific term. So now we're going to take this general and now just put in the place of r a 3. So I'm doing it that is just 1. So it's negative p to the power 3. So I'm using that. And x to the power 3. Then I press on my calculator 5, NCR 3, and I get 10. Negative p to the power 3, x to the power 3. Okay. Now, I'm telling you that coefficient, there is the coefficient, okay, that is equal to the 2160. So if I'm just going to say that equals negative 2160, then I divide 10, and this is negative, then you see it can actually just cancel out. Otherwise, just take the cube root of this, and I basically just get negative 6, but the value of p will be 6. So I think I could have actually just went there. I just want to take a red. I could have just go there already, get rid of the negatives there, and then say the cube root of 216, and I will also get my answer is 6. And that's how you do it. Okay, let's look at the examples. Again, I want you to stop the video, and I want you to do number 1, 2, 3, and 4. And again, do it like this. Do 1, and then check if you are correct. Do 2, check. 3, check. 4, check. Okay. But I'm just going to start with number 1. The coefficient, and it's again x to the power 3, and then they give you the expansion, it's to the 4, is 144. Find the possible values of the constant p. Okay, now I'm first going to find that, and this is also, so I first want to write it down. So p plus 1 over p, and then it's just going to be x, and it's 4. Okay, so first find the r plus 1 term. And that is going to be, okay, now remember there's a 4, so it's 4 over r. Then I take the first term, which is p, and then I'm going to say 4 minus r. And then I take the second, or I can just take, I'm going to break it up, that part. It doesn't matter. So it's going to be 1. Let me rather just put it in there. I just want to move it. Okay, I'm just going to redo this. Okay, so it's actually the second term, 1 over p x, and it's to that power r. So if I break it up, so it's 4r. This one I already have. So p, 4 minus r. Now break that in 3 parts. So make it 1 to the r. Then it's p, bring the p up. So make it negative 1r. And then the x is already on top. So r. So if I simplify that, then it's p, 4 minus r. Okay, now this is just going to be 1, so it can actually just fall away. And this one, I can actually, there's a p and there's a p. So if I want, I can even, I just want to show you. Oh, sorry. Yes, I can simplify this piece and make it 1. So it's negative r and another a negative, so it's negative 2r. I can already simplify. And then x to the power of r. Okay, so now I can say 4. I'm just going to think I'm going to go in white there. So for the term x3, we are going to have x to the power 3 equals, just focus on the x, xr. So therefore, I can already see that r is going to be 3. So I'm going to go on. So the term containing four, 3, okay, let's just move it up. And then it's going to be, oh, let's just move it up, up. So it's going to be p, and I'm just substituting there. So it's 4 minus 2, 3, and x, 3. Okay, so press in your calculator 4 NCR 3, and what do you get? You get 4. Then p, this is going to be 4 minus 6, so it's p to the power negative 2, and then x, 3. This must always come to that, otherwise you made a mistake. Okay, so basically this is again my coefficient, do you see, of x3. And I said, can you remember, that 4, I can actually put the p here, and that is equal to 144. I just made the exponent positive. And then I can cross multiply, and if I cross multiply, I get 144 p squared, and that's equal to 4. So I divide 144, I divide 144. So I get p squared, and that is going to be, 4 can go in 1, it goes in 36, it's 1 over 36. And then, don't forget, it's just p, so therefore, p, and now it's plus minus 1 over 36. And what will that be? Plus minus 1 over 6. Just always read the question again, because sometimes they just ask the positive value. But if I read it again, so find the possible values. So that's meaning the positive and the negative of the constant p. And that's how you do number 1. Example number 2. Let's start. The coefficient of 1 over x in the expansion of this is 720. Okay, so let's just go and first write it down. So 2x plus a over x squared to the power 5. And the coefficient of this is 720. I can just underline it. Now, let's start with number a. Find the possible values of the constant a. Okay, now again, always start by first finding the r plus 1 term. Okay, so I'm just going to write it rather here. So it's going to be that 5, and then I keep it open, r. Then I take the first term, and top minus bottom. And I take the second term and just the bottom. And then I just spread it out, or just make every base an index. So it's 5r, so it's 2 to the power 5 minus r, x to the power 5 minus r, a to the power r, and then x, don't forget, it's -2, and then you go to r. So you have to first bring it up to the numerator. Okay, let's simplify it further. 5r, and then this is going to be 2, 5 minus r. I don't see another base with this, but I see another base here. So if can I just show you? I see an x and an x, and I must make it 1. And I like to put it at the back. So bring the AR, that's all right, and then x. Now this is 5 minus r minus 2r, so it's 5 minus 3r. Okay, and now I'm just going to start the sum. So I'm going to say 4. Let's just go to another color again. So for the term 1 over x. Now remember, 1 over x is x to the power -1. Okay, we equate. Okay, and we work here. So it's going to be x to the power of, it doesn't matter where I write it, so -1. It doesn't matter which one you write first. Okay, but it's just that we're going to take this, and take it in red, this, and equate that. Okay, now I'm just going to get, so the bases are the same, so I can put the indices equal to each other. And then it's 3r, it's 5, there's the 5, the 3 becomes positive, and it's another 1. So 3r is 6, too long, so r is going to be 2. Okay, now I'm just going to substitute it back into the green. So the term containing 1 over x. Okay, and now I'm just going to say it's going to be this 2, so 5, 2, and now I just substitute it there. Okay, and let's just start with that process. So it's going to be 2, and it's 5 minus 2, a to the power of 2, and then x to the power, and then this must be the same as the 1 over x. So 5 minus 3, 2. And that is going to press on your calculator. So 5 NCR 2, and that will be 10. Okay, then 2 to the power of 3, which will be 8. And then a 2, and then x, and this must be -1. Okay, otherwise I made a mistake. Okay, so then it's going to be 80 a squared, and I leave it like this, but you can, it's actually multiply 1 over x, just showing you that it's that term. Okay, but now I still want to find that value of a. So go back to my sum, and I said that that is equal to 720, the coefficient. So I'm just going back, and I say, okay, so therefore 80 a squared, and that is equal to 720. And then I'm just going to get a squared is 720 divide 80. Okay, so a squared equals, and if I simplify that, I'm going to get 9. So a equals plus minus the square root of 9. So therefore a is equal to plus minus 3. Okay, that is my first part. Okay, but now I just have to go, I'm just checking quickly something. Okay, now I also have to do b. Oh, it's quite a long sum. So hence, that means use that answer. Find the coefficient of 1 over x7 in the expansion. Okay, now I need some of this information. I think we can just make space. It's fine. I'm just going to, remember a is plus minus 3. I'm going to make a bit of space here, but I'm going to leave my general term. I'm going to leave it up to here. I'm going to start to change things from there. Okay. So from here I will start with B. Just remember A was plus minus, not square root, plus minus 3. Okay. So let's just say term, remember it's 1 over x7, which is actually x to the power negative 7. We equate. And what do we equate? It's again that. So we're going to say x to the power negative 7 is equal to x to the power 5 minus 3r. Okay, so we're going to get negative 7 equals 5 minus 3r. Bring that 3r over, it becomes positive. 5 plus 7 is 12, so 3r is 12. So therefore, r is going to be equal to 4. Okay, and now for the term containing, let's just go on. So for the term, I would rather like it if it's a bit lower. Okay, so okay, for the term containing x to the power negative 7 or 1 over 7, it's going to be, and let's just put it here. Oh, sorry. So it's going to be, remember it's 4, so it's 5, 4, and then it's going to be 2. I'm just going to substitute into that. Do you see there? I'm just substituting in there. So it's going to be 2, and it's going to be 5 minus 4, and it's 8 to the power of 4, and x, 5 minus 3, 4. Okay, so 5, 4, and that will be equal to 5, and that will be equal to 2, just 2. And this will be a4, and this will be x, and this will be power negative 7. So that's going to be 10a4 x to the power negative 7, or multiply 1 over x to the power of 7. And now I'm just going to say, okay, if a is free, let's see what do I get then. Then 10, and I put 3, and okay, we will see what's happening. X minus 7, and that is going to be 810 x to the power negative 7. But, and it's due to the even number. So if a is negative 3, check then, it's the same. Because now it's going to be 10, and it's negative 3 to the power 4, x negative, and then it becomes a positive also. Okay, so basically then it's just, this is going to be 81 times 10, so then it's also going to be 810 x to the power negative 7. So therefore, and I end up, therefore, the coefficient is 810, and that is my final answer. Let's start with number 3. It's actually good before you start with number 3 to check the example 51 on page 93 in the grade 12 AS-Level Mathematics textbook, y equals mx+c to success, because it's almost exactly the same. So if you can do that one, number 3 will be easy. Okay, but to refresh your memory, I'm doing this one for you. So the coefficient of 1 over x, so it's again 1 over x, it's a coincident, in the expansion, but now there's 2 parts. Do you see? There's 2 parts, is 74, and there's a plus in between. So find the value of the positive constant, and now look here, positive constant. So always read the question again at the end. But, so I'm going to do, it's almost like I'm going to do double. Okay, so I start with the yellow. So the first, I'm going to start, and this will be for both of them. Or, no, not actually, because it's 2 different brackets. So, I'm starting with this bracket. That's the yellow one. So, it's going to be kx plus 1 over x, also a coincident, 5. So I start and I say the r plus 1 term. Okay, and that is going to be, okay, so let's just going to say, so it's going to be 5r kx to the power of 5 minus r and 1 over x to the power just r. Okay, so I'm first going to break it up. So I get 5r and then k 5 minus r, x 5 minus r. Now that one is fine, you can just leave it out. But bring the x up, then it's x to the power negative 1, or you can just directly go to r. Okay, so the next step is going to be 5r, then it's k 5 minus r, and now I just make that 1. So x 5, so it's minus r, so minus 2r. Okay, now for the, let's just keep to the yellow. So for the term 1 over x, and don't forget it's x to the power negative 1, we equate. And what do we equate? We equate this, so, or we can say x minus 1 equals that x 5 minus 2r. So I'm going to say negative 1 equals 5 minus 2r. Bring the 2r over, bring the 1 over, and I get that the value of r, 6 divided by 2, and that will be 3. Okay. So now, so I'm completing this. So the term containing 1 over x to the power of 7. And now I'm just going to put 5, 3. Okay, I put that 3. Oh, I say 3, but I write r. So 5, 3. And then I'm there. Do you see? So it's k. So it's 5 minus 3, x 5 minus 2, 3. And that is going to press on your calculator 5 NCR 3. And what do you get? 10. And it's going to be k squared. And it's going to be x negative 1. Okay. So just that is going to be your first part. Okay. There is your coefficient. I'll come back to it. Now I'm first going to go to the blue. So what was the blue? Do you see? There is the blue. So let's just start with that blue. Then I'm going to say, okay, for the bracket, 1 minus 2 over x. And now this is to the power of 8. Okay, now I start the whole process over. So I'm going to say, for the r plus 1 term, I'm going to say it's going to be 8 over r. Then the first term, now I can use the special case, but for now I'm just going to go in my rhythm. So grab that sign. Don't forget to grab that sign, r. Okay, so then I'm going to go, just get the pen. 8r. Now 1, can you see it's just falling away because everything will just be 1. But I can say negative 2, so grab the sign there and then r. But then remember, if the x comes up, it's negative 1 and then it's r. And then I'm going to say 8r. And this is going to be actually negative 2. Leave it like this. X to the power negative r. Okay. And now I'm going to say the term contact for the term for the term 1 over x, or remember x negative 1, we are just going to equate. So we equate. Okay, it doesn't matter which one. And this is just to this. Okay. So therefore, I can already see that r will be 1. Negative r will be negative 1, but r will be 1. So the term containing containing 1 over x7, it's going to be 8, 1. Okay, are you with me now? I'm just in there. Do you see? So it's negative 2 to the power 1 and then x to the power negative 1, which is, if I press 8 NCR 1, then I'm just going to get 8. This is going to be negative 2, and this is going to be x negative 1. But that coefficient is going to be, let's just get my pen, negative 16 x to the power negative 1. Okay, now I'm just going to make smaller that you see both, because I want you to see both. Okay, I'm even making still smaller. Okay, because I'm going to work here. So I'm sitting now with the blue and I sit with the yellow. But remember, originally, and I didn't write everything down, and I'm just going to write it down now for you. Originally, I had, and I'm just going to write it here. So it was kx, oh, sorry, I just don't want to close that bracket, plus 1 over x to the power 5 plus 1 minus 2 over x to the power 8. And that there, it was equal to 74. Do you remember? So now I have this coefficient, which I'm bringing in. So it was that 10k squared, that's the coefficient. I want to make it white. So it's that 10k squared. So it's going to be 10k squared plus, and now I'm going to the blue, and what was it? Just negative 16. So it's actually plus or negative 16, doesn't matter. Come on, pen. Come on, come on, come on. Come on. Negative 16, and that will be equal to 74. Okay, so it's actually 10k squared equals that 74 plus 16. Okay, so I will have 10k squared and 74, that's going to be 90. Okay, so I divide 10, I divide 10, I get k squared is equal to 9. So k is equal to plus minus the square root of 9, which is plus minus 3. But, and now this is always very important that you read your question again. Just the question part. I'm going to make it bigger that you see. So the question part was, and I'm here. So find the value of the positive constant. So therefore, and I'm ending in red, therefore, the positive constant, so therefore k is equal to 3. Okay, I could have actually left just that. So the positive constant, therefore k is equal to 3. And that's how you do it. Okay, I just want to mention, because I saw a question like this and it was also beautiful, but then it was not just a plus, then it was just saying this is equal to this. So you can just play around with this white part at the end, but you have to get your separate coefficients in the first case. Okay, let's start with the final question in this video. It's actually taking a little bit long. Okay, but let's start. Number 4. The coefficient of x to the power of 4 in the expansion is a. The coefficient of x to the power of 2 in the expansion is b. So it's just almost like you do both of them in the same. It's almost like two questions that they just combined. Okay, but let's start with the first one. So I'm just writing first the bracket down, and this is going to be my green one, just to help a little bit with the colors. So 2, so x squared plus k squared over x to the power 5. Okay, so remember what we are going to always first do. We're first going to find the r plus 1, the general term. Okay, term. And that is going to be, take that 5, take the r, take the first term in the bracket, and say top minus bottom. take the second part, second term in the bracket, and just say r. And now I just simplify it. Okay, so if I simplify it, I say 5r, and then it's 2, 5 minus r, and it's x, and this is 10 minus 2r. And then it's k, and this is 2r. Remember, if it comes up, it's negative 1. So I'm just going to do this in 1. So it's negative r. Okay, because you have to bring it to the numerator. And now, usually, I just want to simplify this, the x, and put it at the back. So r, and then it's going to be 2, 5 minus r, then k, 2r, and then x, and this is going to be 10 minus 3r. So I just simplify this. Okay, and now I'm going to say for the term x4, we equate x to the power 10 minus 3r equals x to the power 4. Sometimes I put x4 on top, front, something, doesn't matter, as long as you have both. As long as you have this and this, bring together. Okay, so then I'm just going to equate the exponents. So I'm going to say, no, I want to keep it to green. Just get my colors a little bit, help you. 10 minus 3r equals 4. So now just sitting with a negative. So 4 minus 10. So negative 3r equals negative 6. So therefore, the value of r will be equal to 2. So then the term containing x4, it's going to be, now remember, it's that 2, so 5, 2, okay? And now I'm just substitute it in there, do you see? So it's going to be 2, so 5 minus 2, then k, 2, 2, then x, 10 minus 3, 2. Okay. Okay, and now I'm just going to simplify this. So 5, if NCR 2, that is going to be 10. This is 2 to the power 3, and that's going to be 8. And it's K, 4, and X, and it's 10 minus, so it's going to be 4. So this is going to be 80 K4 X to the power of 4. And now, remember what they said. Go back to the question. Okay, they said, the coefficient of x4 is a. So then I can say, therefore, this is the coefficient. So therefore, a is equal to 80 k4. Okay, the value in front of x to the power of 4. Now, I'm going to go on to the next part. Okay, so now I'm sitting with the coefficient of x2 in the expansion is b. So I start again with my expansion. Okay, let's just go. Now I'm just in the yellows. Okay, so let's just write down that bracket first. I just want to get that bracket. I just want to see it again. So it's 2kx minus 1. So 2kx minus 1, and that's to the power of 4. Can I just check it again? 2kx minus 1 to the power of 4. Okay, so for the r plus 1 term, okay, take the first one, so 2kx, okay, sorry, yes, it's fine, I can, okay, let's rather start again. Okay, so it's going to be 4 over r. Then the first term, I unfortunately just forgot the front. So it's 4 minus r. Then the second term, grab that sign, and that's just 2r. Okay, and then I simplify, and I'm going to get 4r, and then it's 2, 4 minus r, k, 4 minus r, x, 4 minus r, and then negative 1 to the power r. Okay, actually I'm just looking for this one. So if I see basically that there are just one, I can just work with that. So I say for the term x2, we equate. So it's going to be x2, and I'm working with that, x4 minus r. So 2 equals 4 minus r. So r is equal to 4 minus 2. So the value of r will be equal to 2. Okay, but now I must get that term. So I'm just going on with that term containing x2. Okay, so don't forget it's 4, but that's the value of r. It's also a 2. And then I'm just going to that step there. So it's 2, 4 minus 2, k, 4 minus 2, x, 4 minus 2. And this negative 1 will not have an influence, but let's just write it. And that's to the power 2. So press with your NCL. So it's 4 NCR. So 4 NCR2, and that will just be 6. 2 to the power of 2, that will be 4. Then it's k to the power of 2, x to the power of 2, and that will just become negative 1 will just be 1. So that will give me 24 k squared x2. Okay, so again that, so therefore the coefficient, so 24 k squared is equal to b, or b is equal, doesn't matter. Okay, now again I'm going to make smaller, and I'm going to go for that final. Okay, so now I'm just back at the question, and they say given, and I have to make first just a bit bigger that I can see. Okay, and then I can there. So given that a plus b is 216. So let's just start. So where is my values? Okay, I want to say, but as long as I see the a and the b, okay, okay, there is all. So a plus b equals 216. Usually I don't write next to each other. It's just now because it's so long. So then I'm just going to, there is my a, I substitute, so 80 k to the power 4 plus b, 24 k squared. And they can play around with any type of equation where you're just going to substitute in. Okay. So this is going to be, and again, I love this. It's again a combination with chapter 1. Why do I say that? Because that's a reduced to quadratic form. So if I'm going to, I'll just get my pen again. So k4 plus 24k squared minus 216, and that's equal to 0. Okay, you can say divide 2, or divide 4, but at the end, if you divide by 8, you're going to get 10k to the power 4 plus 3k squared minus 27, and that's equal to 0. And now I factorize, and if I factorize, I get 9 times 3, and I get 5 times 2. Okay, so this is 15, and this is 18, and this is group B, and if I subtract, I get 3. Excellent. The biggest overcross gets a positive and a negative. So basically, I'm going to get 5, and remember this is k squared. So 5k squared plus 9, 2k squared minus 3, and that's 0. So 5k squared plus 9, so I'm doing long, or 2k squared minus 3 equals 0. So 5k squared equals negative 9. So k squared, can you already see what's going to happen? You cannot find the negative, so you can already say no solution. You cannot get the negative square root. Okay, but this one, it's going to be 3, and this is going to be k squared equals 3 over 2, and then k is going to be plus minus, and you can just leave it like that. That is your final answer. Okay, a very long sums, but really not that difficult. Make sure you can conquer these sums in the examination. Now, again, it's such a long video that I decided that I will just show you the bookshops in this video, and I will leave the last video, the last of binomial theorem, will not be so long. So basically, I will give the notes to the teacher, how to order textbooks through the ministry for your school to make it easier for your students. I will do that information in the final video that will be part 3.